All right, last topic in chapter 4, and this will be a quick one. I'm just going to do one example because it's a lot like a lot of stuff that we've done before. So here's what a system of linear inequalities is. 3x plus y is less than or equal to 9, and 5x minus 3y is greater than or equal to 2. So it sure looks a lot like a system of linear equations, only we have less thans and greater thans instead of equal signs. So just like so, before we graphed solutions to inequalities, to just one inequality, and we said, okay, there's a lot of different x's and a lot of different y's that satisfy an inequality. So much so that we can't even write them all down. We have to literally shade in a part of the plane. There's only graphical ways to represent the solution set. There's no real other way to represent the solution set except just to literally point to this inequality and be like, these numbers. So that's what we do. We draw a little xy plane, we chop it up, and we shade in a region of the xy plane, and we say, okay, every single ordered pair that lives in this region satisfies this. So when we did that with a single inequality, we just drew one line. Remember how we got the line just from these? And we said, okay, it's either everything on this side of the line or that side of the line is going to satisfy this. So with these, just picture, we're going to draw two lines. And it's going to be like, okay, everything on this side of this line, and it's also on this side of this line. So it's going to be like an overlap or an intersection of two regions. All right, so just kind of what I said. Just as an example, for something to be a solution to this, just like with equations, they both have to work. So like 2, 1 is a solution, just that I picked randomly, because when you plug in 2 for x and 1 for y, those things are both true. 3 times 2 plus 1 is less than or equal to 7. And 5 times 2 minus 3 times 1 is greater than or equal to 2. Right, so if just one of them is true, it wouldn't work. They have to both be true. So it's not even like finding the points. It's just drawing them on a graph. Right, so that's what you do. You just do them as two separate problems, basically. And then you say, well, and then you just see where both of the solution regions overlap with each other. All right, let's do it. 2x plus y is greater than -2, and negative 5x plus 3y is less than or equal to 27. It could be that there are these kind of inequalities that actually don't have solutions, but it'd have to be a pretty specific case. But this will. Okay, so you just treat them like two separate problems. So the first one you just say, okay, I've got to solve 2x plus y is greater than -2. So remember how to do that. You graph the line 2x plus y equals -2. And then since it's not inclusive, you're going to use a dashed line because the actual line itself isn't included. Like that. So I don't know how you guys are graphing 2x plus y equals -2, but however you're doing it, do it. That's what it looks like. And use dashes just to indicate that actually anything on the line doesn't count. Okay. Now we need a test point. So remember how we do that? The easiest way to do that is just to use the origin. So plug 0, 0 into this first inequality and just say, okay, is 0 plus 0 greater than -2? Actually, yes, it is. So everything that's on this side, the side that includes the origin of this dashed line, is a solution to the first one. Testing. Ooh, this is tricky. Okay, so just shade that in and do it in such a way, well, you're going to need to shade some more later. So don't get too nuts with shading and don't use a pen. Okay, so that part makes the inequality true, the part of the region of the plane that includes the origin. Okay, so get that because that scribbling is actually about to disappear, but it'll come back. All right, so now just literally do the same exact thing with the other inequality. Take -5x plus 3y equals 27, graph it however you do that, and then be sure, so that line should be solid because this is inclusive. Okay, so the stuff on the line is included. Pick a test point, pick the origin, say, okay, is at 0, 0, is 0 plus 0 less than or equal to 27? Yes, actually it is. So this chunk of the plane on this side of the solid line satisfies it. So I'm going to kind of not pencil it yet, but what we've got is that since they both include the origin, it's like this. This is the border of the region, and then it's anything to the right of it. Like that. Okay, so now we just have to say, okay, here's all the gray stuff, here's all the red stuff. What's both gray and red? And it's where they overlap, and that's going to be blue, and then it'll look better. Okay, so it's any of the blue stuff. Or even better, like that. Okay, so it's still a region of the plane. It's just not, like a half plane or whatever. The region is defined by two lines. Okay, and that's it.